Here's a lie we tell about math. That you take a problem, turn a crank, and out pops the answer, one clean, straight line. But real modeling almost never works like that. It's a loop. And the most important arrow in that loop points backwards. Let's meet the loop. 5 steps. Recognize the problem. Formulate a model. Solve it. Check it against reality. And present it. Sounds tidy, right? Numbered 1 through 5. But watch what actually happens. To make this real, let's take the smallest problem I can think of. A hot cup of coffee sitting on a desk, cooling down. Simple question. How does its temperature drop over time? That's our problem. Step 1, recognized. Step 2, formulate. We need variables and an equation. Call the temperature T and time T. Now, the simplest guess anyone would make? The coffee just loses a fixed number of degrees every minute. Constant cooling. In symbols, the change in temperature per unit time is minus some constant K. Step 3, solve it. This one's easy. A constant rate of change gives you a straight line, sloping down. The coffee cools and keeps right on cooling at the same steady pace forever. Step 4, check it against reality. And here's where it falls apart. A straight line doesn't stop. Follow it long enough and your coffee drops below room temperature, then below freezing, then colder than the room it's sitting in. That's absurd. The real data curves and flattens out. And this is the whole point. The check didn't hand us an answer. It handed us a problem. So we don't move forward to step 5. We go backward to step 2 and fix the model. That backward arrow is not failure. It's the engine. Not failure, the engine. So back to formulating. Here's the fix. The coffee doesn't cool at a constant rate. It cools faster when it's much hotter than the room, and slower as it gets close. The rate depends on the gap. So we write, the change in temperature is minus K times T minus the room temperature. Round the loop again. Solve it, and now you get a curve that dives fast at first, then eases off, gently leveling out right at room temperature. Check it, and this time the curve lands on the data. Newton's law of cooling. The loop closed. Notice the tension we just lived through. Too simple, and the model loses touch with reality. That was the straight line. Too complex, and you can't solve it at all. Good modeling walks the tightrope between those two. Simple enough to solve. Faithful enough to trust. Only now, step 5. Present it. Because a model nobody understands is worth nothing, no matter how clever. You show the curve, you show it matches, you make it clear. That's not decoration. It's the last real step. So that's the shape of modeling. Not a straight shot from question to answer, but a loop you travel again and again, each pass a little closer to the truth. Recognize, formulate, solve, check. And around again. The line was the lie. The loop is the method.